All right, hello everybody. We're going to be taking our notes for Unit 1, Section 3 today. So if you haven't already, go get your green sheet, get that out, and open up to the page that says Section 3, Mixtures. If for some reason you forgot your green sheet, right, we should be taking the green sheet home every single time you go home. But if you did forget it, you can follow what I'm doing on the page. So go to your Canvas homepage, click on Class Resources. All right, and then we're going to go click on this link that says Green Sheets, and we can find the Section 3 green sheet right here. You can download it, and that should download as a Google Doc for you. I'm going to do the little preview here to show you what it looks like so you can get the right page out if you have your packet. All right, so you should be looking for the page that has Section 3 up at the top, and we're starting with Mixtures in bold at the top center. All right, so make sure you're at that spot. Press pause if you need to, and I'm going to get started. Alrighty, so we're going to be focusing on mixtures. Right, so mixtures are not pure substances. In a mixture, each substance keeps its own original properties. Before I go on to that, a great example of a mixture would be Chex Mix, right, or a trail mix. Think about the individual pieces in that mixture, right? A pretzel is still a pretzel, right, no matter if it's in the Chex Mix or it's out of the Chex Mix. When we put it into the mix, it doesn't change its identity or its properties. It is still a pretzel. That's why we would consider the whole Chex Mix as a mixture. Most of the stuff that we see in nature is a mixture, so that contains two or more pure substances mixed together, and they can either be heterogeneous or homogeneous. You might be familiar with the prefixes of these words, hetero meaning different and homo meaning the same. And we have three types of mixtures that we're going to focus on. So when you fill these in, I would also put a star next to these because you must know what these are. We have a solution, a colloid, and a suspension. Right? And while you're there, I would go ahead and I would definitely star the heterogeneous and homogeneous as well once you put in the definitions there. So for heterogeneous, you might want to put different or it does not look uniform throughout. And for homogeneous, you'll want to write the same or looks the same or uniform throughout. All right, so I'll give you a second to copy those down. If you need to, hit the pause button. I'll be here waiting for you. All right, so we're going to be talking about solutions versus colloids. I know we haven't done the investigate yet, so bear with me here. But we're going to be looking at, and the difference between these mixtures is the size of the particles. So the difference in the particles is that solutions have the smallest size particles, right, while suspensions have the largest size particles, and colloids are in the middle. Colloids are very, very small particles, but not as small as a solution. Right. This might not be on your green sheet, so over to the right of where we wrote solution, colloid, suspension, probably a good idea to draw this little diagram that we have on the page. All right, so when we go into solutions, right, an example of a solution would be sugar water, right? If you mix sugar into water, right, it kind of looks the same. It doesn't look any different, right? That's because the particles are going to be so small. If we're looking at this, right, on the macro sense, right, it just looks like a spoonful of like a white crystal. But when we zoom in on the micro, right, we can see that they're actually these small rectangular or cubic crystal shapes, right, and they all have that square or cubic shape. Right, when we get to the nano view, when it gets very, very small, right, it's going to still retain the same properties. So imagine these being even smaller, so small we can't see them with a microscope, right, as small as one molecule. So it looks super small. right? About 40 million molecules in just one of those cubic crystals, right? That is a lot, right? Almost too much or too small to fathom. Right? And this is what one of the sugar molecules would look like. Alrighty, so when we're looking at the solution of sugar water, right, in the macro sense, it just looks like a glass of water. In the micro sense, right, we can't see much. We can't see anything with a microscope. It still looks like a glass of water, but at the nano view, right, we can see that those particles of sugar are still in there. The sugar and the water have not combined to make a new chemical, right? The sugar has just dissolved to be so small, right, separates down to its molecules that we can't even see with a microscope. Right, but it is still in there. It is still a mixture. Right, so, all right, so we're on to the notes for solutions here. So we haven't written anything down for the past couple minutes, but a homogeneous mixture, solutions are a homogeneous mixture that contains a solute and a solvent. All right, these are two very important terms. You might want to star these as well. So a solute is the dissolved substance, or the substance that is being dissolved. So in our previous example, the sugar was our solute because we dissolved it into the water. And the solvent, right, is typically water, but it's generally or always going to be a liquid that dissolves that solute. Right, but oftentimes, right, we call water the universal solvent because it dissolves many, many, many things. When we pour a solution through filter paper, right, it should pass straight through the filter paper, all of it. Both the solute and the solvent will pass through. And some examples that we can write in for solutions would be salt water, sugar water like we just talked about, soda, and iced tea. Right? Iced tea is basically sugar water with some flavoring from some tea leaves as well. Well, at least if you make your tea like I do. Very sweet. All right, next one we're going to talk about will be colloids. Some examples of colloids would be milk, dust, and fog. Right, these are very tiny particles, right? Not as small of particles as a solution, but they're still very, very small. And these particles never settle. Right, so these particles are too small to be separated by filtration. Right, the colloid would pass completely through filter paper. But we can see the particles of colloids with a microscope. Colloids look or appear homogeneous to the eye. So when we're just looking at a glass of milk, it looks like one uniform mixture. But we know under a microscope that it's actually heterogeneous because we can see, right, it is not uniform throughout. And one thing that will be present in colloids and not in solutions or suspensions is what we call the Tyndall effect. Right? So the Tyndall effect is when we can see a stream of light, right, reflect and refract off of those small particles in the mixture. So in a solution, the particles are too small and it will pass right through. We will not get any reflection or refraction of the light. And in a suspension, the particles are too big, right? They will stop that light from passing through. Right, so we will show you this video in class. This is from the Big Bang Theory. So what they did was they're actually playing a fancy game of chess, but they spray some dust in the air, and that creates a colloid in the air around them, so the laser beams are visible to them. Right, and here's another example. So when we have a colloid and we shine a laser pointer through it, right, we can see that laser pointer going through our liquid, right? And this Tyndall effect is the scattering of light by tiny particles found in a liquid or a gas that are large enough for the light to bounce off of it. And that's what I mean by reflecting and refracting. It's just bouncing. You might notice sometimes when you're watching TV at home when it's sunny outside and the window's open, you have this stream of light come through. What that is that's actually the light bouncing off of the small dust particles in the air in your room, right? And those dust particles mixed with the air are creating a colloid that is reflecting and refracting the light, making it visible. And probably hindering the view of whatever you're trying to watch. All right, so if we're looking at these two glasses, which one of these two glasses would be the colloid? All right, so hopefully you answered the glass on the left. The glass on the left, we can see the laser pointer going through the bottom, while the glass on the right, we cannot see the laser pointer at all. All right, and our last mixture that we're going to talk about are suspensions. Right, we're not talking about suspension like you did something bad in school and we have to send you out of here for a little bit. These are suspensions or mixtures with the largest size particles. Right, these particles are large enough that we can separate them with a filter. So if we poured our mixture right through a filter, the solids, the big solid particles or pieces, would get stuck in the filter and the liquid would pass through. Right. In a suspension, the large particles will fall to the bottom. Right. You can take a look at the Italian, I think that would be Italian dressing at the bottom right there. Right. Your parents might have these sitting on the windowsill in the kitchen or maybe in the cupboard that they use on salads. If you shake it up, right, it's all mixed around, kind of floating around like a snow globe, but then it will all settle to the bottom. Right, a snow globe is a perfect example of a suspension. Right, these suspensions are heterogeneous. We can see with our naked eye that there are different pieces in this mixture. It is not uniform throughout. Some examples would be paint and salad dressing. You can see the salad dressing on the right. I'm not sure if you've ever been to Lowe's or Home Depot where somebody's buying a new can of paint, and what they have to do is they put it in that crazy machine that spins it super fast. And what they're trying to do is they're spinning it so fast to break apart these big particles because the paint is a suspension. And you don't want your paint to be clumpy when you're trying to put a nice even coat on your wall. Alright, so my apologies for the very dark chart that you have on your page here. But if you could take a second, right, pause the video and write in what belongs in those dark boxes. You can write them above the boxes or to the side of those boxes. And once you do that, I want you to fill in what those three blanks are down at the bottom. Okay, so one of them is going to be a solution, one of them will be a colloid, and the other one will be a suspension. So make sure you're putting that in the correct area. Pause the video now, and then you can hit play again when you are ready to check your work. All right, welcome back. So let's go down the left side first. So if your particle dissolves or it disappears when it goes into the liquid, right, and the particles are super, super tiny, right, too small to even be seen with a microscope, you have a solution. So the blank on the bottom left, you should have written in solution. Right, and let's go down the middle now. So again, if your particles still dissolve, it looks like it's uniform throughout. Right? They are very tiny particles, too small to be seen with our eyes, but we can see them with a microscope. That would be a colloid. So in the blank in the middle, you should have written in colloid. And on the right, right, your particles do not dissolve. They are large pieces and large enough to be seen with the naked eye. So the blank on the bottom right should be a suspension. All right, so we have finished notes. What I need you to do before you are done for the day is I need you to finish the Chem2Go section 3 down below our notes. All right, so there are 2 questions there I want you to answer, and then we will go over them next time I see you in class. All righty. Also, if you turn the page in your green sheet, you will notice that you have the West York Area High School bell schedule in your green sheet. I accidentally left that in there when we were doing the copies, so you can rip that out, and now you have a permanent copy of the bell schedule no matter what's happening at school that day. Right, so you will now always be prepared and ready to know what time you are changing classes. So you're welcome. Alrighty, enjoy your night, and I will see you later.